we can begin, now that we've created our account, we can begin using Desmos. Now, what you see is I've already set up a page for this particular lab. There's a few things I'd like to point out. On the left side is going to be kind of all our different data collection, data analysis tools, everything that we need to use to manipulate our graph right here on the left side. On the right side is obviously our graph where all our data will populate and we'll be able to see it and analyze it. You'll notice that we have a X, Y graph here. It is labeled, which is something that you'll do on your own in future lessons. But for right now, I labeled it for you, just kind of make this a little bit easier to read and use. You'll also notice that on the graph and in the data table, there's already some data here. I put this data here just to give you an example of what your graph could look like by the end of this lesson. Now, there's two columns within our data table. We have a column for T. T represents time for this particular lab. And D represents distance. And that should make sense because the two ways you're measuring the motion of your Dune Buggy car are with a meter stick and with a stopwatch. Now, with your table mates, you guys have to figure out how are you guys going to measure time? How are you guys going to measure distance? And then what does that look like to actually input it into a data table? Right. So first things first, you can go ahead and delete all this data. Notice as I delete it, the data points automatically disappear from your guys' graph. Right. As you guys are collecting data, you'll notice that different data points will automatically pop up within your graph. Now, if you scroll down a little bit, you'll notice that there's 4 different equations. Now, these equations may not look familiar, but they may have a similar pattern to what you guys have seen before. Below those equations are 2 different sliders. Now, we're going to play around with this, particularly the slider on line 8 that says m equals a number. Now, you notice if we click on that slider icon and begin moving it back and forth, all the lines on this graph will change. Now, each of these lines are what we call a line of best fit. Right? These are meant to be patterns that average out the data that we have. Our goal with our data set today is to mess around with the slider until one of these lines begins to fit our data. Now, I made up some data that ended up being a perfect fit. But the reality is you guys are probably going to get some data that's a little bit messy, right? That's why we call these lines of best fit. You just want to figure out which line best fits your data. It may be that it doesn't touch any of your points, but kind of sits in the middle of them or is close to them. Maybe it goes through a couple of the points, but not all, right? Some of this may depend on how many data points you have. If you only have one single data point, it'll be a little bit difficult to figure out a line of best fit. Usually you need at least 2, but the more the better. You'll notice there's also a second slider here. If we mess around with this, you'll notice that the line will change as well. So once you have all your data inputted, what you want to do is mess with both of these sliders until one of these lines fits your data, becomes a line of best fit. Now, once you figured out which line is your line of best fit, in this case for me, it's the red one. What I can do is I can clean up my graph and get rid of some of these other lines. You'll notice that each of these colored lines corresponds to one of these formulas. I have a green kind of curvy U-shaped line here and a green dot over here. If I click on that green dot, it disappears. Same for the purple one. Same for the blue one. And I want to deselect all the graphs that don't fit my data in order to be able to make a clean analysis. Now, a key thing here is I found which line fits my data. I can look over here and see that the red line matches this formula. Now, I just need to figure out, what do these letters mean? Why are there letters in science? Why are there letters mixed with math? That's when it all went downhill. The reality is, each of them are a placeholder. We already know that D is one of the things that we measured, distance. T is another thing we measured, time. Now, for the M and B, we can just figure out, does that have any connection to the sliders down here? Talk with your group and then figure out, using this graph, this data, whichever equation you found, and whatever these sliders ended up being or equaling, can you determine how fast your car was moving?